All right, let's go over how to solve some arc length and sector area problems on our homework arc length and sector area. It starts off with just a couple, find the measure of each angle problems where you're given a reference angle, then you got to figure out the whole way around to that terminal side. So what I'm going to do is I'm just going to start tracing my angle and counting in radians as I go. So each half, if this is, well, this one I'm going to count in radians. Actually, both of them I'm going to count in radians because the reference angle is given in radians. So as I go, each half turn is pi radians. So here I've gotten pi to here's 2 pi. 3 pi there. So 3 pi to there. From here to here, we know that a quarter turn is pi over 2. And then it gives us the rest of the way to our terminal side as being pi over 3. Since all of these pieces are part of the overall spiral to reach that terminal side, I'm just going to add them all together. And here's where we have to be good at our fractions. So 3 pi plus pi over 2 plus pi over 3. I need to get everything to have a common denominator, so the easiest common denominator would be 6. So I'm going to multiply this one by 6 over 6, put it over 1 so that it's a fraction, multiply this one by 3 over 3, multiply this one by 2 over 2, and now I've got 18 pi over 6 plus 3 pi over 6 plus 2 pi over 6. Or that's 23 pi over 6. And then at the very end, we check in to see if that was positive or negative rotation. This is counterclockwise, which we know is positive. Also, the first move of that spiral is to go up, meaning that it's positive. So final answer, 23 pi over 6. All right, for our next, well, I think we're good there. There was another video to help with angle measures. Let's get into arc length and sector area. Find the length of each arc. This is a very easy formula. It's just arc length S equals R times theta, R being the radius, and theta being the angle, but it's very important that it's in radians or this formula will not work. And we can see in these first examples here, they're all given in radians. So S equals 4 times pi over 2. This equals 4 pi over 2, which equals just 2 pi. But that's just a number. 2 pi is just a number around 6.3. This is a length, so it needs a unit of length. So it's 2 pi feet. I get the unit from my radius there, 2 pi feet. Another one, S equals R theta. S equals 12 feet is the radius. Theta is 7 pi over 6. I'm going to multiply that 12 to the top of the fraction to get an 84 pi over 6, which equals 32 pi over 3. If I divide the top, no, 42 pi over 3. If I divide the top and the bottom by 2, and divide the top and the bottom by 3, and I will get, let's see, that's 30, the 10, the 14 pi, and then I got to grab my unit from the radius, 14 pi feet. All right, let's move on to maybe some sector area problems. These are all arc length. Find the area of each sector. All right, to find the area of a sector, so just like this piece of a circle, we can find the whole area of the circle and then just multiply it by the fraction that this piece represents. So the whole area would be pi r squared. In this problem 11 here, the whole area would be pi times 17 squared. 17 squared, I do not have memorized. I'm going to look that up. 289. So the area of the whole circle is 289 pi inches squared. This 5 pi over 4 is what percentage of the whole revolution? Well, the whole revolution is 2 pi. So if I just divide it by 2 pi, I'll figure out what portion of a full revolution it is. Let's make that a 2 pi over 1 so that we can do copy.flop. 5 pi over 4 times 1 over 2 pi. There's a pi on the top and the bottom, so I'm going to cross simplify here before I make this 5/8 times 289 pi. 5/8 of 289, let's see. Is 180.625. Let's turn that into just an improper fraction. It is 1,445 over 8. But the pi hasn't canceled, so it's 1,445 pi over 8. Let's give it the correct unit, inches squared. All right, let's try that again. With number 13, go through that process again, all the way through one more time. So to figure out the area of just this sector here, I need to find the area of the whole circle and then multiply it by the fraction of the whole circle that this angle is. So the whole circle is pi r squared, which would be pi times 4 squared, or 16 pi square meters. 3 pi over 4 represents what fraction of a full revolution? To figure that out, we do 3 pi over 4 divided by a full revolution, which would be 2 pi. I can make that a 2 pi over 1 without changing it, so that I can do copy.flop to do this division. The pi's cross simplify. Now we've got 3/8. So this angle here represents 3/8 of a full revolution. I'm going to take that 3/8 and multiply it by the 16 pi meters squared that we already have. And that is going to be 6 pi meters squared after I do the multiplication. All right, let's call that good for this homework. Have a good rest of your day.